think we should start to think about the final report because we're kind of at the end of the experiments. Well, I know that there's 3 more weeks, but I don't have any other ideas or any other possibilities that I can think of that we should figure out. We know the good range, we know that it works, we know that it's not dangerous, we know almost everything that I think is relevant. So I think now we should rather focus on the final, and for that we should make a table of contents. So I think that would be the most important. Because if we have a table of contents, then we can divide it, it's clearer, you know what you want to do. And later, after the other point that I think we should discuss is the meeting that we are going to have with the first year students, like lecture on Friday. So I don't know which one would you like to start with?
I thought that we go with the lecture first.
Okay, let's start with the lecture.
Supposed to do, and we just comment on each slide what was good or not good, for example, and what it comes out of the meeting. We just said for the Lemnak Pro, I don't think it was super good because it was a new idea, like eco-friendly, not with chemical and stuff. So if it works, it could be super nice for him. And if it don't work, it's gonna be like, for him it's a problem because for him no result, it's no result. And the amount of the words is still result. So I don't have the same opinion, I can understand. But
well, it's quite supposed to work like the other 2 groups are just supposed to this one, so it's supposed to work. But they are
yeah, I think we still have, even if we don't have a result, I think it's still good. But he asked us to have like another plan if
well, we have the micro administrative on this map.
we can still discuss it with that tomorrow.
The first question is, what is not essential for Lemnak growth? There are 4 possible answers. One is phosphate, nitrate, potassium. Our next question is, what is the best pH range for growing duckweed? There's ranges, so it's the first is from 6.5 until 7.5. Okay, the others. Yeah, there are the others. Yeah, basically like it requires relatively pH neutral environment, so basically 6%, but it can also survive. Gentlemen, we are going to present our experiments with Lemnak. And here are the project members. We are group 5, and let's start with it. So, well, what are we going to talk about? First, we are going to have a short introduction, which is going to include what is the problem that we were trying to find the results. And then we are going to present what are the projects and the laboratory results that we have already done, so what is in the past. The next section is going to be about the next steps, what we are going to do in the future, and finally we are going to give you a short conclusion to see what is the total sum of the presentation. So first, the introduction. Well, actually our goal was to find new ways, or we experimented to find new ways to grow Lemnak. And well, for this we used given wastewater and chicken ashes samples that was provided by the client. Well, and we also wanted to make sure that it's not only working in small conditions, like laboratory circumstances, but if you scale it out to a bigger portion, that it's still going to operate in the same way. So, and well, because that's basically the headline of our client, we were after trying to make the next step to close the loop, so make it sustainable as much as possible with reusing all the equipment that we have. So, well, in conclusion, well, we are like relatively close to the results, and to close the loop to provide an environmental friendly and reusable, renewable methods for solution for the problem. Although it still requires some investigation because it's not 100% sure that it's going to be as effective as we think it's going to be. And well, we also wanted to suggest more that other processes should be also investigated and developed